Let's look at some of the characteristics of ionic and covalent compounds. First, we'll see whether they conduct electricity or not. For this, we take this experimental setup. In this, we have a battery. This metallic rod is connected to the positive end, and this metallic rod is internally connected to the negative end of the battery. This battery is further connected to the bulb. The bulb will only glow when there is a complete circuit. In physics, you have studied that electricity flows when there is a closed loop or a complete circuit. So electricity will flow only when there is a complete circuit, and only then the bulb glows. So right now we see that the bulb does not glow. That means the circuit is not complete. Now if we join the two metal rods, so when we join the two metal rods, you see that the bulb glows. This is because as the positive and the negative metal rods are joined, there is a transfer of electrons from the negative rod containing excess of electrons to the positive rod which has a deficiency of electrons. So as the electrons flow, when the circuit is complete, you see that the bulb glows. Now let's take a beaker. So when the beaker is empty, you see that the bulb does not glow. That is, the circuit is not complete. We add some solid salt in it. Again, the bulb does not glow. That means this salt is not conducting electricity. Now we add some water to this salt. That is, we prepare a salt solution. And what do we see? We see that the bulb glows. So when we make a salt solution, the bulb glows. This means that this salt solution is conducting electricity, which helps in preparing a closed loop or a complete circuit. Why does solid salt not conduct electricity, but salt solution, it does conduct electricity? What is the difference in the salt solution? Let's see what is happening. So this is solid salt. If we look inside this solid salt, we see that these are the solid salt, that is NaCl crystals. So when this crystal is put in water, the ions separate. Now this NaCl crystal, when we add in water, we see that the ions, that is the positive sodium ions and the negative chloride ions, they separate out. How do they separate out? Let's see. Now these are water molecules. In water molecules, you know it is H2O. Oxygen is more electronegative than hydrogen. So oxygen attracts the shared pair of electrons more towards itself. So the oxygen end is slightly negative and the hydrogen end is slightly positive in nature. So when the water molecule comes, it attaches itself to the NaCl crystal, the negative end, that is oxygen end, it attracts the positive Na+. And the positive hydrogen atoms, they attract the negative chloride ions. Let's see what is happening. So the positive hydrogen atoms, they take away the chloride ions, and the negative oxygen atoms take away the positive Na+. So the process continues and all the ions, the positive ions and the negative ions, they separate out. We know that electrovalent compounds are held together by strong electrostatic forces of attraction. So in solid NaCl, the ions cannot separate out. And from this experiment, we have seen that ions are required for the conduction of electricity. How these ions help in carrying electricity, you will study later. But these ions help in the conduction of electricity. When we make salt solution, the ions of NaCl separate out. But in solid NaCl, the ions are held together by strong electrostatic forces of attraction, so they cannot separate out. Hence, solid NaCl does not conduct electricity. What happens if we heat the solid NaCl? As we heat it, it changes into the molten state. The attractions between the positive and the negative ions, it gets weakened on heating. Since the attraction gets weakened, the positive and the negative ions separate out, and even in the molten state, since there is presence of ions, so even molten NaCl conducts electricity. So for conduction of electricity, we need ions. Solid NaCl cannot conduct electricity as the ions do not separate out. Aqueous NaCl, that is salt solution, and molten NaCl, that is in the molten state, the ions separate out and so they can conduct electricity. So ionic compounds, they give ions only in the aqueous state or in the molten state. This process is known as dissociation. That is, the ionic compounds dissociate to give the ions. So this process in which the ionic compound dissociates to give ions in the aqueous state or in the molten state is known as dissociation. Now what happens for covalent compounds? We know there are two types of covalent compounds, polar covalent compounds and non-polar covalent compounds. In non-polar covalent compounds, both the atoms are similar. So one atom cannot attract the shared pair of electrons towards itself, as both the atoms have equal electronegativity. This means there is no separation of charge. So if it is made to react with water, the negative oxygen atom and the positive end, that is the hydrogen atoms, they cannot separate the two chlorine atoms. So in this case, when we have a non-polar covalent compound, since there is no separation of charges, on reaction with water, the ions or the atoms do not separate out, so no reaction takes place. Now what happens if we take a polar covalent compound? For example, HCl. In HCl, chlorine is slightly more electronegative than hydrogen. Since chlorine is more electronegative, it tends to attract the shared pair of electrons towards itself. So as it attracts the shared pair of electrons, it becomes slightly negative, and hydrogen therefore becomes slightly positive. So now if it is made to react with water, the ions separate out as there is separation of charges. But this H plus is not stable on its own. So it goes and combines with the negative oxygen atom. In the process, it forms H3O plus, as this H plus goes and attaches itself to this oxygen atom. So it forms H3O plus and chloride ions. So in polar covalent compounds, since there is separation of charges, the ions separate out when we add water. So polar covalent compounds, they give ions only in the aqueous solution. If we heat it, it does not give ions. So polar covalent compounds, they give ions only in the aqueous state. This process is known as ionization. So we have seen that the ionic compounds, they give ions in the aqueous state or in the molten state. But the polar covalent compounds, they give ions only in the aqueous state. We know ions are required for the conduction of electricity. So the ionic compounds and only the polar covalent compounds, not the non-polar covalent compounds, only polar covalent compounds and ionic compounds, they conduct electricity. Ionic compounds are held together by electrostatic forces of attraction. Covalent compounds are held together by intermolecular attraction. It is known that the ionic bond is stronger than the covalent bond. This means that the electrostatic forces of attraction are stronger than the intermolecular forces of attraction. So let's compare some properties of the ionic and the covalent compounds. Since ionic bonds are stronger than the covalent bonds, ionic compounds are generally solids in state. For example, solid NaCl, etc. Since the ions are strongly held together, the ionic compounds are generally solids. Whereas the covalent bond is weak in nature, So therefore, the covalent compounds are generally liquids. For example, the acids like HCl, they are in liquid state, and all the gases, for example, oxygen, nitrogen, chlorine, they are all covalent compounds and they are in gaseous state. So the covalent compounds are generally liquids or gases, or at times they are soft solids. Since the ionic bond is stronger than the covalent bond, so the melting point and boiling point of ionic compounds is high, and the melting point and boiling point of covalent compounds is low. As the electrostatic forces of attraction are very high, in order to break the bonds, the melting point and boiling point of the ionic compounds is high, and since the intermolecular attractions are weak, so for covalent compounds, the melting point and boiling point is low. The property which is characteristic of an electrovalent compound is that it is easily vaporized, it has a high melting point, it is a non-electrolyte, or it often exists as a liquid. We know that electrovalent compounds have electrostatic forces of attraction. These forces of attraction are very strong, and this is the reason why they have a high melting point. Since it's not easy to break the bonds, or that is the ionic bond, so the electrovalent compounds have a high melting point. So these are some of the characteristics of ionic and covalent compounds.